I should, so slipping occurs or no slipping occurs? Slipping occurs between the blocks. Now slipping occurs means what we should do? They will have different display, they will have different accelerations, they will have different displacements in a given interval of time. So let's calculate acceleration of them separately. At the same time, we have to discuss the work done in different frames. So here FL, this applied force. Okay, this is about the, you wait till end of the problem. Huh? Just do make observation rather than asking some things. Okay, here they will have like this. So what is the acceleration A1, A2? We'll calculate separately. No, A1 is equal to FL by M1. What is FL? 8 by 2, 4 meter per second square. What about A2? F minus FL by M2. 26 minus 8 by 3. 26 minus 8 will be 18 by 3. 6 meter per second square. These are the activities. What is the displacement now? Work done by friction will calculate here. Work done by the, with respect to one, 2 frames. Person P and there's another person Q. Yes, definitely. Will they be same? No. So first with respect to person P. Where is the person P? On the ground, no? You write it on the ground. Now get into the thing now. Work done by friction with respect to P on the ground. Work done by friction on the block. We are just bothered only on the block. Let's see. Even on the block M2, you can go for it. Let me focus only on the block. So work done by the friction on the block M1. So what you're going to write? FL into displacement of block. How to calculate displacement of block? What is the formula? X1 equal to AT square by 2. What is the time given? 2 seconds. Acceleration is how much? 4, 2. This will be 8 meter. Similarly, we'll calculate X2. Should be equal to A1. No? This is A2. A2 is how much? 6, 2 square by 2. 12 meter. Let's come for this. So this is how much now? FL is how much? 8 into this is 8. 64 joules. This is what? With respect to person P. Same friction, what work it will do with respect to Q. How to find out? Now person Q, what will come in? Block at rest or block in motion? Block M1, moving, that one you will see. So with respect to person Q, little bit the diagram we have to change it. I'll move this. Now come for this one. With respect to Q, what will happen? What we did with respect to person P on the ground, work done by the friction on the block M1. With respect to Q, we'll calculate. I'll take it here with respect to Q. Where is on the plank or block, anything you say, on the plank M2. Then how to do the problem for this? What you have to do is, we don't know what direction the block will move here, no, with respect to plank. Am I right? Actually, in what direction the block will be moving with respect to plank, we are not sure. So first we should have a clarity of that. We know this is the acceleration E2. So where is the person? Person Q is here, no? Let me introduce here. What is this? You will notice a pseudo force. Now ask yourself like, which
Thank you,
force
sir.
will be greater? Which force will be greater, M1A2 or FL? I think we have to look at this. So what is FL? FL is 8 Newton, no? No, what is A2? A2 is 6 and M1 is 2. So which force is greater, M1A2 or FL? Definitely M1A2. So this will become A relative. So I'll proceed like this. M1R equal to M1A2 minus FL. Sir, how do you can see? I have enough data here, no? 2 into what is A2? This A2 is what? Pseudo force. Again, I'm making clear. I'm just putting thick arrow indicates pseudo force. Now, tell me why pseudo force? Because who is solving this problem? Your teacher or the person Q? Person Q. Of course, I'm only solving. I'm just asking you to imagine you are on the plank. You are on the plank and you are looking at the block. Then what you see? The friction FL is acting, then pseudo force. Check the value of M1 A2. A2 is how much? 6 minus FL is how much? 8. So 16 minus 8, 8 and M1 is 2. 4 meter per second. So what is the direction of this? Towards left, no? So person Q, what it says? What be its comment? The block M1 is moving towards left. So friction does positive or negative work.
Sir, AR is 2, sir, 2 meter per second square.
So 2AR is 4 newtons.
Which one?
12
Yeah.
minus 8 is
This is 12 minus 8. This is 4. Okay, then I'll change it. Yeah, thank you. Now, what is AR? This is AR is what? Displacement of acceleration of the block with respect to Planck. I'll calculate XR also. What is XR? AR T square. We know we are very good in relative velocity, no? I'll apply the same concept. So this is 2 in 2 seconds is asking 4 meter. So what is XR I should call now? Displacement of block M1 with respect to Planck M2. In what time? In time interval 0 to 2 seconds. Okay, got this. I gave enough information. Okay, let's calculate the work done by the friction. Work done by the friction on the block M1 with respect to Q, no? With respect to person Q. Where is on the plank or non-inertial frame, you write it. Anything it's left to you on the ground, no? Is on the plank M2. Where is he? Is on the plank M2. So what you'll write equation, no? FL into XR, not X1. And I'll put negative sign. Why negative sign? How FL is acting? Towards right. But the displacement of block with respect to Planck towards left. So we know the value of FL. FL is how much? 8 Newton. Displacement of block 4 minus 32 joules. Just look at the thing here. So once again, to show that if a force does positive work in one frame, it may do negative work in other frame. It may do zero work. It may do more than that, less than that. So work done is different in different frame of reference. That's for this particular statement. You have this very small statement in SU Arma. Work done is different in different frame of reference. Maximum students, they just do remember. But you look at the problem, no? You are supposed to work out. You should take example, you have to analyze. What is work done by the applied force? I think that was the question that is asked. No, I think we left that. We didn't bother. So I'll just put it here. We'll just conclude that one. We'll just do it here. Work done by applied force with respect to what? With respect to ground. How much it should be equal to F into X2. So what is the displacement of the blocks? 12 meter, and F2 is how much given? How much we took? Where is the thing? 26 Newton. Yeah. X2 is how much? 12. This much is what? Work done by the only on the plank, because applied force is acting only on the plank here. And what is this FL? Work done by friction. Work done by friction on the block M1 with respect to plank M2. Okay, no, so there is, I think definitely it's a real big headache for you students. It's not that easy that you straight away you go and some constant equation to write, some laws of motion, not like that. Here we should be thorough in what, like going through the problems in all sense.